Yeah, like today I'm going to explain you about the important topics in unit 4, short answers and both long answers. So you can note down the each and every topic so which I am coming across. For each and every topic, I'll give you the short answers as well as the long answers. So this fourth unit we are having two sub chapters. Three subchapters we are having in this, basically creating architectural design, component design, and user interface analysis. So for your internal point of view also, you will have these important questions only. So no need of asking me again. So important topics for the unit 4 and unit 5. So whatever the important topics under short answers and long answers I am giving, so that you can expect in the internal as well. So you can make a note of them. First one, creating architectural design. So basically, this chapter is focusing on what are the architecture, what is architecture, and what is an importance of an architecture, and what are the various kind of architectural styles and patterns we will follow when we are considering the software. And at the same time, so it will talk about the alternative for architectural designs and how we can convert an entire software or the entire data flow into a software architecture. So these are the main key areas which wherein this chapter will focus on. What is an architecture? What is an importance of an architecture? What are the various architectural styles and patterns are there? And is are there any alternative architecture designs are there? And at the same time, we are going to map a data flow into software architecture. So what is an architecture? So what is an architecture? So this one is like we can expect sometimes 2 marks question. What is an architecture? Define an architecture. So simply the architecture will give you about the blueprint of an entire system. So architecture will give sometimes if you are taking as an hardware project, it will give the physical aspects of a system. Okay, physical aspects of a system will be covered in as a part of an architecture. So the architecture of a system is a comprehensive framework that describes its form and structure, its components and how they fit together. For example, uh, 8085 architecture, what it will give, 8086 architecture. If you are talking about the architecture, it will give entire blocks which are available in that particular processor block diagram. So the architecture mainly will give an major information about the major components which we are using. Okay, so in the similar way, if you're talking about an software architecture, it will give complete overview about the modules, what type of modules we are using, functional aspects of a system it will cover. So the software architecture system is mainly used for representing the structure of the system, so which consists of various components, and at the same time the externally visible properties of those components and the relationships among them. It is, for example, drawing a class diagram, what are the main classes you are going to have in that class diagram, and the relationship between the class diagram. So that is a structural aspect of a system which can be also called as an architecture. So structural aspect are the external properties, external visible properties, and the relationship among the classes it will cover. So this is about an architecture. What is an architecture? Define an architecture. So architecture is used for giving the information about the blueprint, so which acts as an major aspect of a system, and it will give the structural representation of a system, and what type of components we are using in that structure it will uh, tell basically. So what is like architecture this is, and why it is important, what is the need of studying an architecture? So if you want to know, if you want to understand an importance of an architecture, it's important, you can make a note of it, why architecture is important for 2 marks question. So the architecture is important to understand, why? Because it will give a communication between the various parties like stakeholders. The first one is it will give a communication between the various stakeholders who is going to interact with the system. And second one, it will focus on the engineering work and ultimate success of the system. And the third one, it will focus on the uh, s- smallest units of a system, So wherein if we are going to combine them, we will get the final system. So each and every smallest unit which we will take, and if we are combining them, we will get a large system. Means combining unit testing, and we are going to integrate all of them, and we are going to check the functionality of the system. So for these three reasons, we need to understand an architecture. We need to have an knowledge about an architecture. So why is an architecture important? So the architecture is important. Why? Because it will give a complete information about the stakeholders who is going to interact with the system. And second one, what kind of decisions we are going to take while we are implementing the entire system. And third one, what are the main modules we are going to use, and how we are integrating them to check the final functionality of the system. For these three reasons, we need to know about an architecture. Okay. And the data design at the architectural level. So this is not this one is important. Data design at the component level. So if you are talking about what are the set of principles that we will follow when we are talking about the data specification, this is long answer wherein you are having 7 principles. So set of principles for data specification are, what are the data specification principles? Okay, are, so how we are converting a design model into analysis model with a set of principles. So same question, how we are converting an evaluation from the design model to the analysis model, and what are the various kind of the principles that we are following in the data specification, and what are the principles for the data specification, or enlist the data specification principles with an example. So there are you can see total 7, as I mentioned you, 7 principles are there. So the systematic analysis principles applied to function and behavior should be also be applied to data. So these are the 7 principles which we need to follow. Okay, so this is an important question. So all data structure and operation to be performed on each should be identified, and mechanism for defining the content of each data object should be established, and low level data design decision should be deferred until late in the design process, and the representation of data structure should be known only to those modules, and a library of useful data structures and operations that may be applied to them, and a software design and programming language should support the specification and realization about the data type. So mainly, if you see about this set of principles, what it is talking about. So if you carefully observe this, these principles are mainly talking about the uh, core components of a program, wherein what kind of data structures we are going to use, what kind of attributes and operations we are going to perform, and at what extent we can implement them while we are while we are coming across in the different phases in the design model and analysis model. So mainly these principles are talking about the data specifications, wherein privacy, security also it will consider. So what kind of information hiding, so how, in what way you are going to hide an information. Okay, and we are going to keep all data structures and the function at one place. So these are the set of the principles wherein mainly focus on the data and the data hiding and the data security, data privacy, and at the same time data structures and the functionalities which we are implementing, and type of attributes and the operations which we are going to perform. So each and everything will be explained in the data specification principles. So this is an important long answer wherein 7 principles are there. And one more very important topic is, what is a pattern? So this is for short answer. What is a pattern? So pattern and the architectural styles, two things you will have basically. What is the difference between pattern and architectural style? Also, you will get sometimes as a 2 marks question. Okay, so architectural styles means how we are going to develop an entire project. So each and every project will be developed in various ways. So which kind of architectural style you are following? So there are 5 architecture styles are there. So that I will show you. It is a part of long answer, very important for internal exam and the external theory also. So explain various architectural styles with suitable diagrams. Okay, draw and explain various architectural styles with suitable diagrams. And in the similar way, patterns also we will have. There are 3 patterns are there. So when we are talking about the patterns, so I'll explain about the patterns also. So what is an architectural style and what is pattern? These are the two short answers which you can expect. So architectural style is like transformation part. So wherein if you're taking an entire design of a system, so how you can transform a design, so will be explained by an architectural style. For example, you want to follow the uh, data centric style, means one central server you will have and all clients you will have, or you want to follow call and return procedure, okay, or you want to follow the layer architecture. So which kind of strategy you want to follow, so that will be explained. Design transformation will be called an architecture in simple way. Okay, the transformation that is imposed on the design of an entire system, how you are going to transform an entire system into a design. Okay, so this is called as an architectural style. Fine. Where is an architectural pattern? So which is almost similar to an architectural styles, but it imposes on the transformation and the design of entire system, wherein pattern consists of number of fundamental ways. What are the main fundamentals? Means each and everything will be called as one pattern. When you are transforming this architect into an architecture, what kind of pattern you are following, it will give an information. Architectural style and the pattern difference is, so patterns will be used for translating an entire system into architectural styles. So that is the relationship between pattern and the architectural styles. Okay. So we are making use of a patterns, set of the patterns. So the patterns are used for translating an entire system into an architecture. Okay. So an architectural style is transformation that is imposed on the design of an entire system, wherein an architectural pattern like an architectural styles which imposes a transformation on the design of entire system. So a pattern differs from a style in number of fundamental ways. What it is? So scope of pattern is less broad and focusing on one aspect of an architecture. And the pattern will describe how software handles some aspect of its functionality. And architectural pattern bend to address specific behaviors issue within the context of architecture. So these are the fundamental ways wherein we are going to differentiate architectural styles and the patterns. So what are the architectural styles we will follow when we are going to design an entire system, which is very, very important. So you can make a note of it. Explain various architectural styles with suitable diagrams. Architectural styles with suitable diagrams. Okay, so the first one is a data centered. As the name itself is indicating, we are having one central server, each and everything will be connected to the client. It is, for example, a database. A data store resides at the center of the architecture and is accessed frequently by other components that update, add, delete, or modify within the data store. So multiple clients can perform this kind of the scenario. So this will be called as a data centered architecture. So at center part you will have an server, or at center part you will have the database, and all clients will be performing an operations like update, delete, add, and modify. This kind of scenario will be called as a data centered. As you can see on my screen, data centered architecture. And the next one, data flow architecture. So wherein here we will have filters. So this architecture style, one filter in output will be given as an input for the next filter. So the architecture is applied when input data are to be transformed through a series of computational components in output data. So pipes, connecting parts, which we can call it as the pipes. A pipe and a filter structure as a set of components called filters. So connected by the pipes. So which transmit the data from one component to the next component. So one filter output will be given as an input to the next filter. So each filter works independently and produces the data output of specified form. Okay, sometimes we can say it as in sequence also. There will not be like this stepwise fashion, you will not have. So sequence means definitely it should take an input from the previous and that will take from the previous. So in sequence fashion you will have chaining system you will have. So if the data flow degenerates into a single line of transform, it is termed as a batch sequential. So this one is batch sequential. So this structure accepts a batch of data and then applies a series of sequential components to transform it. So one and after another you will place it, and based on that you are going to carry the information to the next level till the end of the completion you will have that. Okay, so data flow architecture and the batch sequential are two examples under the data flow architectural style. And the next one, call and return. It is just like subroutines. So which how we will execute in the programming language. In the similar way, we will have call and return methods. So call and return methods, call like main function will call and sub function will return the value to the main function. So it enables a software designer to achieve a program structure that is relatively easy to modify and the scale. So which operation you want to perform, that will have function. So that function implementation we will do at separate place, and if you want to make use of that function, you will call it, and based on your call it will return the value to the called function. We know this one. So main program and the sub program architecture. Okay, so like main program you are having here. So this main program, whatever you are taking here, so this will act as a main program. So this main program is having the multiple sub programs like here 1 2 3, and which is also connected here. That line is missing. This is connected. Three sub programs which we are having, and again it is having the sub programs. Okay. So this kind of representation will be called as an call and return. Remote procedure call also, like some of the famous method, remote method invocation, RMI. Okay, so wherein we will use this scenario in the case of the Java RMI, remote method invocation. So the components of main subprograms architectures are distributed. So in distributed systems also we will use remote method invocation and the core bar. Okay, the components of main subprogram will be called, and which will be distributed across the multiple computers on the networks. So these are the methods which we will use when we are talking about the call and return architecture. You can take any of the example and you can explain. So main program, other subprograms only we are having anyways. And next one, object oriented. We are very much familiar with this approach. So class based representation. Okay, wherein one main program will be implemented with the help of the multiple classes. So one main program will be implemented with the multiple classes. Each and every class will be having set of objects, and it will perform set of it is having set of attributes and the operations. So the components of system encapsulate data and the operation that must be applied to manipulate the data communication, and coordination between the components is accomplished by the message passing. So each and every class is going to exchange a messages, and these messages which we are using are used to carry out some operations between the classes. Okay, so main you are having, and some of the classes which we are going to implement it in object oriented architecture. And the last one is the layered architecture. So it is just like an operating system. If you want to implement an operating system, so the operating system will be implemented in the layers. So utility core layer, utility layer, and application layer, and the user interfaces layer. Okay, so this kind of architecture will be called as an layered architecture. So, software engineering also we can call layered technology. Why we are calling it as an layered technology? So it will also have some kind of information like architecture components. Okay, user interfaces. So like that we will have application. In the similar way, we are having layered architecture for an operating system if you want to go with. So number of different layers are defined, and each accomplishing operations that progressively became closer to the machine instruction set. So core are utility, application, and the user interface layer. Okay, so this is an example for an operating system. So these are the 5 main architectural styles which we need to explain with the help of the suitable diagrams. So this is very important long answer question. Almost 95% of the question papers you can find this architectural styles with suitable diagrams. So make a note of it. What are the various types of architectural styles are there, and explain with the suitable diagrams. 5 architectural styles: data center, data flow, and call and return, object oriented, layered. Okay. And next one, what are the patterns, architectural patterns? So if A and B are there, so the A and B questions directly, they will ask architectural styles for long answer directly, and we need to explain all of them. But whereas in case of this architectural patterns, AB one of the bit you will get. So what are the various architectural patterns? Explain explain architectural patterns. So like architectural patterns define a specific approach for handling some behavioral characteristics of a system. So because architectural pattern is going to give an input for an architectural style. So as I mentioned you, three we are having here: concurrency, persistent, and distribution. Concurrency, persistence, and distribution. Enlist architectural patterns. So that is for short answer. Enlist architectural patterns: concurrency, persistence, and distribution. Okay. So these architectural patterns. So concurrency will be like multiple simultaneously executing any processes are there. We need to identify like parallelism. If you want to take a parallel processing and parallel execution of an application, then we will go with an concurrency. So most of the time, schedulers and an operating system will follow this kind of an aspects, means layered structure. And persistence. So persistence, like data stored in the database or the file may be read or modified by the other processes at a later time. When it is executing, we should not do that. Later time we can modify it. So two architectural patterns that we will use here under the persistence is DBMS pattern and the application level persistent. One is in the database side and one is at the application architecture we are using. And the distribution, so which is used for addressing the manner in which systems are components within the system. So wherein they are communicating with each other in a distributed environment. So as I mentioned you, RMA and the request broker agent like Corba. So that those are the some of the patterns which we will use. So broker pattern, wherein middleman will be there. So it is just like publish subscribe. If you are subscribing for any messages, they will publish it. If you are not subscribing, then they will not publish it. So we need to subscribe. So the subscribing which we are doing will be then like broker. So one company will be there in the man, a middleman will be there, and we need to contact that middleman, and this will send a message. You need to send an information to them. So when we are subscribing to the this broker, then this broker will send the messages. So this is an broker pattern. So distribution will concentrate on communication in a distributed environment. So persistency will talk about later, we need to modify it, not during an execution. And concurrency will talk about parallelism. So concurrency, parallelism, persistence means modifications later, distribution means communication in distributed environment. These are the short terms wherein you can keep in your mind. This is about an architecture pattern. Okay. So next thing that comes to our mind is architectural design. What are the various architectural designs that we will follow? Architectural styles is design, architectural design is design. Different. You need to understand. Architectural styles are 5, patterns are 3, architectural designs are different again. Okay. So the architectural designs, so representing the system in context. So architectural context diagram, what it is? It is just like a DFD diagram. It is DFD diagram only, but it is represented in different way. So wherein we are having actors and the subordinate systems, superordinate and subordinate systems, and the peers and the target system. So when you are having peers and actors and superordinate and subordinate system, what is the target system you are going to implement? Means who is going to interact with the system. Okay, so the representing the system in context. Architectural context diagrams, these are ACDs. What are the ACDs? ACDs are DFDs. Before DFDs, we will talk about ACDs. If you are explaining them in the architectural point of view, then it can be called as an architectural context diagram. If you are explaining them in the design, then it is a data flow diagram. So the architectural diagrams and the data flow diagrams, similar relationship we will have. If it is in architecture, then it is ACD. If it is in design part, it is an DFD. Okay. So referring to the figure, we are having multiple terminologies here. Superordinate systems means higher level of processing scheme. Subordinate means lower level you will have. And next one, pair level systems means clients who is going to interact with the system. And actors, the main person who is consuming this. So those persons will be called as an actors. Okay, for example, you see target system, security function. surveillance function will be acting as a peer, and sensors will act as an subordinates, and superordinates are like safe home product and the internet based system, and users are control panel and the homeowner. So architectural context diagram for the safe home security function. So sometimes you will get this one directly. Okay, this one safe home uh, security function. Draw a architectural context diagram for safe home security function, which is there in the textbook. Okay, so this one sometimes you will get an direct question. At that time, we need to draw this ACD. Okay, and next one, designing architecture types. So what are the various architecture types we will have? So following are, so this one, how we will ask the question. So architectural design. So draw and explain an architectural design with suitable diagram. So safe home security function we are going to explain here. Safe home security function, architectural design. Okay, this refinement will be done in the multiple stages. So same thing. So controller, if you are talking about refinement, we are going to do architectural type. You are going to do controller is having node and detector and indicator. So the communication link which we are showing here, and at the same time how you are going to refine it. So what are the components that are connected to this one? If you extend it, then that one we will be called as an refinement. For example, I when I am explaining it in the class, I gave you one example. A door is there. So door, if you are talking about the door is one component you are having. Just you will tell door is there and how you can, whether you can slide left side or right side, you will tell that's it. Okay. So a door is there, you need to open the door. So when you are talking about the door again in detail, refinement, how you will do, this is a door wherein this door is made with a like metal or the wood, and we need to slide the left side or the right side if you want to open the door, and we need to hold the knob, and we need to slide the door towards the left side, then only it will open. So in that way we need to explain refinement when you are talking about. In the similar way, safe home executive is there. So external communication management, GUI and internet interface is there. And if you are talking about the function selection, security, surveillance, and home management are there. Okay, what are the main things that we will keep here? We need to keep in mind. Okay, this is a refinement wherein we are going to start from here, and this one we are going to identify one sensor we are taking, and then we are refining it here. Okay, so this is an architectural design where we are following. Okay, so alternatives not that much important. This one is again how we can map data flow into software architecture. How we can map data flow into software architecture. That's a question. So with the help of the data flow diagrams, we are going to map an entire data flow into software architecture. So wherein we are calling it as an, we know already one process like transactions which we are having. So transform, we are going to identify the set of transactions like which are coming from incoming and outgoing transactions which we are going to identify. Okay, the transaction flow, and when you are splitting each and every transformation, that will be forming new, again new set of the transactions, so which we can call them as a data flows. Okay, this is the transaction flow. Again it is going to split and we are going to enter it into the different transaction. Okay, so here just you need to explain with an example data flow diagram. Here safe home security data flow diagram is there, as you can check here. Context level data flow diagram for the safe home security function. So this is the main process which we are having, safe home, and these are an entities, external entities which they are going to interact with the system. So what is the level of this one? We know level 0 this is, as we are having only one process inside of it. This is the level 0. So control panel, sensors, control panel, display, alarm, and the telephone lines. Okay, So this is the level 0 DFT, and we are going to extend the functionality of this process into multiple processes, and we can call it as an level 1. Okay, as you can see, level 1 data flow diagram. So you can observe here these 5 are remains same. These 5 remains same, 1 2 3 4 5, but here we are going to add an extra. So now this entire system is represented in the form of multiple processes. So configuration, interact, and process flow, activation, monitor, and the display. Okay, so this one we are calling it as an level 1, and you also draw the level 0 and level 1. But level 2, when you are talking about only configuration, we are going to talk about that refines the monitor sensors transform. So sensors transformation or the monitoring process we are going to explain. Configuration management, this one is a level 2. So in detail we are having in detail information. So when we are talking about an mapping data flow into a software architecture, mapping data flow into software architecture is explained with the help of the data flow diagrams. So level 0, level 1, level 2. So by default he will give a question from the textbook itself, that only we need to explain. Safe home security function. Draw a data flow diagrams in 3 levels. Safe home security function, level 0, level 1, level 2. So this is an topic which is related to mapping data flow into an architecture or the software architecture. Okay, so this is also one of the important question. So how we are going to identify that one? So based on the various flows we are going to identify it. So determine whether DFT has a transformation or it is not having any, and isolate transformation center by specifying incoming and outgoing like this. Like this, where is an incoming and where is an outgoing line. So each and everything will take one incoming and one outgoing line. And next one, so perform first level factoring. So which one, like 1 2 3, if we are having 3 levels we are having, this is 1 and this is the region 2 and this is the region 3 which we are having, and this is the region 4. So if you are taking this is an center part, 1 2 3 will be having here again. So monitor sensors executive. So here we are having, and next one sensors input controller, and next one alarm output. Okay, and finally we are having this one monitor sensors executive. So first level factoring for monitoring sensors. Okay, and we can go for second level, and until and unless we find the final data we can do it. But wherein we are going to focus on this level 0, level 1, level 2. So transformation mapping can be done in 7. Yeah, 7, 5 stages. Oh no, 7 stages it is. So it can be done in the 7 stages transformation mapping. So these main side headings we need to keep in mind. Review the fundamental system, level 0. Review the refined DFD, level 1, level 2, and determine whether we can have further flows. And next one, isolate transformation center by spreading incoming and outgoing flow level boundaries. Means we need to identify like this. And next, first level factoring. This one is first level factoring and second level factoring. And finally, still if you can do anything. So if not, then close it. There is a transformation flow wherein we will have. Okay. And next one. Yeah, next one, modeling component level design. So till this point, so architectural styles, what are an important questions are, what is architecture, why an architecture is important, and what is the difference between architectural style and the pattern, and what are the various architectural styles are there, explain with them suitable diagrams. Enlist architectural patterns. Okay, enlist architectural patterns. So 3 which we are having, that we need to enlist here. Okay, and next one, so architectural design. When you are talking about an architectural design, we need to talk about an entire system representation. Architectural ACDs we need to talk about, architectural context diagrams. And next one, assessing like alternative architectural designs. So not this one. Yeah, mapping data flow into software architecture. So 7 steps. we need to explain here transformation mapping. Okay, so once it is done, then second chapter which we are having is modeling component level design. So modeling component level design. What is component? It's a modular, a deployable and replaceable part of a system. The component is a chapter 2. I am telling what is component. Define component, 2 marks question. It's a replaceable, deployable, a part of a system. So which encapsulates implementation and exposes a set of interfaces. So when you are talking about an component, an object-oriented view, classes you will have. What you will have an object-oriented view. Each and every class you are going to transform into an component. Okay, so when you are talking about an object-oriented view means class diagram, you are going to transform it into a component diagram. Okay, for example, if you are having print job as a class, print job will act as an component, but the component will not have set of attributes and operations. In the regular class, I told you, it will not have set of attributes and operations, but it will have the name of the component and interfaces which you are going to implement. That you will have. All classes can be transformed into a components, but it will not have all the attributes and operations inside it. It will have an interfaces which it is going to implement. So component interface. Okay, that is an object oriented view. And what are the various views a component can be developed? So question is, what are the various views a component can be developed? I repeat, in in how many ways a component can be developed? So first one is an object oriented view, and second one is conventional view. So this is an oldest way where we are going to use various components like physical component or logical or the processing aspects of the system can be called as an components. For example, modules, functional element of an application, or a component serves on the following roles. For example, problem domain components. So control component, problem domain and infrastructure. What are the various types of components are there? Three types of components. Control components like problem domain components and infrastructure components. Okay, problem domain components means complete or partial functional requirements. And infrastructure components is which is used for supporting the processing in the problem domain. So three components we are having. Conventional view will talk about the types of the components. Okay, for example, if you are talking about job management system, read print job and select job management function and develop job cost. And here send to job production. The all pink color which we are having extended versions which we are having. This is a normal and this is a refinement which they have done. So this one and this one. So they have done the refinement. Okay, so first one is an object oriented view, next one is an conventional view, and next one is a process related view. These are the three views wherein we are going to talk about how many ways the component can be developed. Okay, and next one, so designing class based components. So the question is, what are the design principles we have to follow when we are talking about class based components? Principles for class based components. The basic design principles for class based components: open closed, list curve, and dependency and interface segregation principle. So open closed and the list curve substitution and dependency inversion and interface segregation principles. Enlist these four. So short answer. Okay. So already we know this component level design guidelines which we are having. So same here, the component level design guidelines which we are following. So object view and a conventional view, and the next one is process related. Okay, and the last chapter in this fourth unit is an user interface design. Wherein when we are talking about an user interface design, the first thing that comes to our mind is golden rules for user interface design. Okay, golden rules for user interface design. So enlist the three golden rules: place the user in control, reduce the user memory load, make the interface consistent. These are the three golden rules which we will follow when you are designing a particular user interface. A very, very important topic like architectural styles. It is also very, very important topic from this unit. 2 marks and the long answer. Golden rules for user interface design. Place the user in control, reduce the user memory load, and make the interface consistent. Sometimes this question will be asked as an individual. Justify, place the user in control. Justify, reduce the user memory load. Justify, make the interface consistent. Or sometimes directly explain the golden rules of user interface design with an examples. Okay, multiple examples are there. Place the user in control means when you want to access it, what kind of operations that you can perform. For example, if you have designed one software and you are I want to interact with the software. So define interaction module in way that does not force a user into unnecessary or desired actions. So means what you want to do, that only you can do. And provide for flexible interaction. Everyone should understand it easily. Either you want to make use of and text or comments and voice or video or image or icon, what you want to do. Allow user interaction to be interruptible. Like if you commit any mistake, there is an option to undo as well. Okay, streamline the interaction as skill levels advanced and allow the interaction to be customized. So basic to intermediate to advanced, we should take it. And designed for direct interaction with objects that appear on the screen. Obviously, we will do that. So clicking or selecting the particular options which are available on the screen menus. Okay, hide technical details internals from the casual user. Yes, obviously we will hide. Why? Because we should not tell. Like if you click on the button, this kind of story will happen behind the screens. We should not tell that. So just we will give, if you are going for an ATM center, there you will have a provision to insert card, which is very flexible to understand. You need to insert. Once inserting the card, it will tell us enter the pin number. If you have inserted wrong, it will tell us so reinsert, take out the card and reinsert it. In that way we should map, and we should not tell the card is not inserted properly and you need to take out the card and you need to insert it properly. Like 4 to 5 line sentences we should not write. Insert card properly, take out and insert properly, that's it. Okay, and once it is done, so it should not tell us again 2 to 3 lines of information. If you want to continue further, you need to enter an 4-digit password which is issued from the bank, and like that we should not write. Just we need to tell enter pin number 4 digits. Okay, so there we are going to maintain the privacy, like which is hidden. Okay, and everyone, if you have entered any wrong digit, there is an option to remove the digit, like backspace should be provided. Okay, so there may be chance if you are entering 5, instead of entering 5, you have entered 6. At the same time, we need to go the backspace and again we need to enter the proper digit. So like that, we need to provide the user interface. That one is place the user in control. Okay, reduce the user memory load. You should not think of 2 to 3 minutes for taking one decision. Okay, so simply you can access the system. Okay, the remember past action. So you should not give 10 digits, 20 digits pin number. If you give that many digits pin number, then it will be very difficult for us to remember and we should enter the pin number. So we should not put more load on the user memory. Okay, so it should be simple and at the same time it should be easily remember. Like the user has to easily remember the process also. Okay, so like reduce demand on short-term memory and establish meaningful defaults. So easy to, like if there is an option to remember the password if you forgot, like hint password hints we will provide. So such kind of provision we should keep. Define shortcuts that are like intuitive, wherein We need to give shorthand way of representation like add, sub, mul, how we will give in a high level assembly level languaging. In the similar way, we need to give one shorthand way for remembering them. Okay, the visual layout of the user interface should be based on real world, like it is logos. Once you see the logo, you should able to identify that and disclose information in a progressive fashion. So which task and which object, like click if you are going to mention, like we need to click on that when one single mouse arrow we will give. Okay, so in that way we need to design. So we should not put more memory, and we should not give like a more time for the user to perform a single task. Simply when he is enter into that, within 10 to 10 seconds or within 20 15 seconds he has to finish that and he should leave from there. So in that way we have to design. Okay, so after inserting an ATM card, if the machine is taking 1 or 2 minutes time, and again entering PIN number 2 minutes. So if the machine is taking in that way, the person will be there in the machine 15 minutes, 10 to 15 minutes. So no such kind of person will access the machine again in the future. Why? Because it is taking a lot of time for uh, deposit or the withdrawal. So we should not do such kind of activities when you are talking about the particular software and any hardware device. So within fraction less amount of the time it has to accomplish the task. Okay, so that is also reduce the user's memory load and make the interface consistent. Okay, so the allow user to put current task into a meaningful context means provide an indicators like it is just like giving an overview, complete overview about the particular site which we are visiting. Okay, and maintain consistency across family of applications, either tabs which we have implemented in a particular website. So proper headings and subheadings we need to follow. Okay, if past interactive models have created user expectations, then do not make changes unless there is a particular issue is there. So until and unless we should not modify it. So it should work properly, make the user interface consistent. If you are clicking, it should open. If you are clicking 10 times also, if it is not opening, means there is no use of clicking on the particular icon or user interface. So these are the three golden rules which we will follow when we are talking about an golden rules of user interface design. Very, very important topic. Okay, so how to make such kind of user interface? Then three rules we have come across, right? Then how you will do that? So how it is possible? So the user interface analysis and design will give you an solution. So there are four models which we are using here: user model, design model, mental model, and implementation model. The four different models come into play when a UI is analyzed and designed. If you want to design such kind of user interface, first one, user model. How user is thinking, what he is expecting. That is an user model. Okay, so we need to consider all of them. From scratch to advanced, we need to consider when you are talking about user model. And next one, design model. So what kind of data architecture interfaces you are going to incorporate into the user interface, and how the user will understand if you are doing it, like mental model, how you will behave when you are talking about that user interface, and finally how you are going to implement it. So these are the four things we need to consider when you are talking about user interface analysis and design: user model, design model, mental model, and implementation model. User model will talk about who, design model will talk about how, and mental model will talk about in what way they will understand, and implementation, so finally how we are implementing it. So the complete user interface design process. So what is an user interface design process? The user interface design process will follow the similar software development design process only, almost. So user task and environment, like analysis and modeling first stage, and designing, construction, and validation. So analysis and modeling, designing, construction, and the validation. So designing, like construction, which we can call it as an implementation also. So spiral model which we are having here is an interface design, analysis and modeling first one, then we are going with an design, and then we are going with construction means implementation, and we are going with an validation. So this is an user interface design process. And the analysis process, the user interface analysis process. Okay, there are set of questions that can be coming to our mind. So analysis process. Okay, so design process, we need to concentrate. The user interface design process, this is an important question. And next we will talk about the user interface design steps. What are the various steps that we need to follow when we are designing an user interface? Okay, so that is an last one in an interface. The interface, user interface design, when you are talking about here, you will have golden rules for user interface design. And next one, so what are the design and analysis process we will follow? The user interface design process. Okay, the user interface design process. And the next one is and finally steps. So interface design steps which we will have. So totally it's a 4-step process which we are having. So as you can see, applying interface design step, interface design patterns, okay, and design evaluation, and the design evaluation. So the amount of learning required by the users and the interaction time and overall efficiency and memory load on the users, improvised version for the golden rules, the complexity of an interface and degree to which it will be accepted by the users. So this one is the last one, interface design evaluation cycle. So wherein we will have 4 topics only here. Golden rules we are having, and the next one we are having an analysis and design process. This one design interface design process, and next one we are having an design evaluation, interface design evaluation. So these are the main topics so which I have come across in this 4th unit. So I explained you all of them, so along with the 2 marks and the long answers. Okay, so this is about the 4th unit revision. So completely I revised each and every topics which we have come across in that unit. So if you have any queries, you can raise the queries. So I'm just stopping the recording as well, and I will share this video in the YouTube as well. So one more time you can go through before internal examination or else a theory examination, you can refer the same video. Okay, so complete revision about the 4th unit.